In this video we're just going to quickly talk about the relationship between the number of coils and the voltage. So here's our primary coil, okay? Primary coil and secondary coil. Now the voltage, excuse the dodgy symbol here for the AC power supply, but the voltage on the across the input coil we're going to say is V1. The voltage that gets induced then across the output coil we're going to say is V2. Okay, and then obviously we've got a certain number of coils on the input coil and a certain number of coils on the output coil. Now I've already shown you earlier that here we've got 3 coils, here we've got 6 coils. So the ratio of coils is 3 to 6 or 1 to 2. So I've already shown you earlier with numbers that look, if this is 10 volts on the input here, we're going to get an output voltage of 20 volts. So the ratio of the coils is the same as the ratio of the voltages. Okay, so what we're saying is the ratio of the voltages is V1 over V2, and that's equal to the ratio of the coils, which is N1 over N2. Now, I haven't proven this equation to you, I haven't shown you a proof of it. I've just stated to you that I know that the number of coils, the ratio of the number of coils, is equal to the ratio of the voltages, okay? And from that we've come up with this equation. You can actually derive this equation. What I mean by that is prove this equation using the laws that Michael Faraday came up with, who was the scientist who did a lot of work on electromagnetic induction. So he did a lot of work on electromagnetic induction, and if you know Faraday's law, you can actually prove this equation. But we don't need to do that. You just need to know this equation and be able to use it. So V1 is the voltage across the primary coil, and that's in volts. V2 is the voltage across the secondary coil, and again that's in volts. Now remember, instead of voltage we could say potential difference. N1 equals number of coils on primary winding, and N2 equals number of coils on the secondary side of the transformer. Okay, so that equation, you need to be able to use that.